Hey folks, so this is Shetz, and before we had to show that the three angles were congruent, and then all the sides were in proportion. So now we actually have some shortcuts here, and with the angle-angle similarity, all we need are two angles congruent. There's one angle, two angles congruent. We know that triangles add up to 180, so then these third angles must be congruent. And once we have angle-angle, then we know any triangles are going to be similar. But remember, they're not going to be congruent. They could be if it's a one-to-one, but they will be similar. Another theorem we have here, we don't need all three angles and all three sides in proportion, is this side angle side. So we have a side, an angle, and a side. Notice that this angle is the included angle between the two sides. Once we have that, we know the two triangles are similar. Those sides must be, and the sides including the two angles must be proportional. This side must reduce to the same as this side. They have to be in proportion. And now, side similarity theorem. Again, the sides must be in proportion. Like 3, 4, and 5, and we would have a 6, 8, and 10. Notice that this is what we had the other day, 3, 4, 5, and 6, 8, and 10. I put the small triangle on top and then the big triangle on the bottom. Notice all of these reduce to a 1/2, so all sides are in proportion. So they're kind of shortcuts for us. All right, we take a look at this example here. Why are these triangles similar? Well, notice my markings. I have parallel markings. I can see I have one angle, a box, and there's another box. And I also know that angle B is going to be congruent to angle D because of they are alternating interior angles. So, by the AA similarity postulate, I know these two triangles are similar. And it says write the similarity statement. So, I will start out with triangle ABC, and that's going to be similar to triangle F is the right angle that goes with A, and B and D go together, and now finally E. So there you go, there's my similarity statement. All right, great. Let's look at this example here. And let me just scroll that up a little bit. Well, right off the bat, I can see that I have vertical angles. Notice these markings right here. That's parallel lines. So I know that angle A is congruent to angle D because of their alternating interior angles. Great. So I know the two triangles are similar. And we're going to write that similarity statement. Triangle ABE is similar to triangle. A goes with angle D right there. B and C would be congruent. And then E goes with E. So there's your similarity statement. Great. So that's by the AA similarity statement postulate. All right, we go on to our next problem here. I have a side, great, so it might be side angle side. I have my angle, side angle. I need this side. Do I know anything about that side? Absolutely not. So these are not similar. Not similar at all. We go to problem 3 here, and right away, I can see this small triangle and I can see this big triangle. I'm also looking at these parallel lines. Well, I know that this angle and this angle are congruent because they are corresponding angles. Great. And another thing I also know is that n is in both triangles, so that would be reflexive. There you go. So these are similar by the AA similarity postulate. Again, I have two angles. And now we'll write the similarity statement. Let's start with the little triangle first. PON. And that's going to be similar to M, triangle, M, L goes with O. You can see that right here. L is next, and then N is reflexive to itself. So there you go. These two triangles are similar by the AA similarity postulate. All we needed were two angles. Now, maybe some of you chose this angle up here and this angle right there because of the parallel lines, and they are also corresponding. So you could have used these three and that one. So there's two angles. I just wanted to point out that N is in both triangles. So that's always look for that as well, reflexive. Let's go on to the next page. So I'm going to split these two triangles up. I have this little triangle here right on the left. We have a 6, a 13.4 it looks like, and also a 12. Great. Oh, and I also have this box here. Let's take this triangle here, this big one, and I'm going to have to flip it so it's right alongside of the other one. There's my right angle. The 12 is going to be here, the 24 is going to be there, and then I don't know this side here. It's not given. So I actually reflected this triangle, so it's right next to this one. All right, well, let's check it out. I have 6 over 12. I must check those sides. And then this 12 over 24. Guess what? They reduce to the same number, a half. Great. So I know these sides are in proportion. And also I have a right angle. So therefore, by the side angle side similarity postulate, these two triangles are similar. So let me get some letters on here. POM, and the O is up. Nope, that's the N is up there. M is a right angle. We have the O over here, and the N is up top there. We have to write the similarity statement. So triangle, I'll go little to big. POM is similar to triangle OMN. OMN. Now it also says find what NO is. We need to find this length right there. Well, I already have my proportion, and here's what I'll do. I'll go 6 to 12. I'll go little to big. 6 over 12 is going to equal 13.4 over x. And when we cross multiply, x will equal a 26.8. So that's what NO is. Notice what it said, find NO. Great. All right. Let's scroll down to this one. Well, we have a fire tower, and you know what? The best thing to do for this is to draw a little fire tower. You're going to need a drawing. We want to find the height of the fire tower, so that's going to be x there. What Letitia does is she places a mirror on the ground like that, and she's going to look down at this mirror, and it's going to be at the very top. So she places a mirror 40 feet from the base of the tower. So this distance along the green grass here is 40 feet. Her eyes are 5.5 feet up, 5.5 feet. I'm using a decimal. When Letitia stands 4 feet from the mirror. So this distance here is 4 feet. All right, great. So I can set up any proportion that I want. And I'm going to do big to big vertical to the, big vertical to the big horizontal. Like that, and that's going to equal, I need the vertical to the horizontal, 5.5 over 4. All right, great. Well, I don't know if you've ever heard, I can cross multiply these, and then divide by 4. Another way of doing this is what we call, maybe your teacher had said this to you, a backward Z. What do I do to 4 to get 40 times by 10? 10 times 5.5 would be 55. So I know x equals 55 feet, and that is the height of the tower. There you go. And we'll hit one more problem here. I know I'm getting quite a bit. The sun is shining on the lamppost that casts a 9-foot shadow. So let me get my lamppost here. Here's my lamppost. Now where do shadows lie? Don't shadows lie on the ground? So then here's the shadow of my lamppost here. And that's a 9-foot shadow. 9-foot shadow. At the same time, we have a person that's standing. How tall is a person? 6 foot. So that person's 6 foot tall, but its shadow, the person's shadow again would lie on the ground, but this shadow is only 4 feet tall. So, and by the way, let's take a little break and go back up to the last problem. Why are these two triangles similar? Because this is a right angle, and these angles right here are going to be congruent. She looks down at it, and so by the AA similarity, these two triangles are going to be congruent. With this one here, here's the sun shining. So we have right angles, and the sun will be at a certain angle of elevation, which is this angle right there and this angle. So again, just like this above problem, angle-angle similarity, these two are similar by the angle-angle similarity postulate. All right, well, let's finish this problem up. They want to know, find the height of the lamppost. Well, the lamppost, we'll just call that x. I'm going to go big to big, x over 9, and 6 over 4. So there's my proportion. And when I cross multiply, I'll get 4x equals 54. Divide by 4, and x will give us a 13.5, and we are in feet. So there you go, folks. Have a great day.